A great pleasure to join my colleagues in welcoming you here and wishing you a great couple of days. You're a very special group of people, and it was nice that you had a chance to meet one new person. This group, through the Baltics and beyond, is important because you are laying down the fabric of geographic knowledge. And my view, my personal view, is that your work is some of the most important work that's going on in this region, perhaps in the world. So I want to acknowledge you for getting in this field. You made a good decision. It's the right decision. Your work has probably never been as important as it is now. Helping your organization, helping others understand our world, and also delivering business value, like so many of those examples that were shown demonstrate. Your work, in many ways, is covering all of the issues that our world is facing. Issues in society, issues in environment, issues in efficiency, issues from water resources to climate change. And I want to start this meeting by simply reviewing with you some of your work and your colleagues' work that's going on around the world. In the world of environmental modeling and assessment, you're looking at wildlife, habitats, air quality, water quality, doing air pollution monitoring and modeling. In the field of natural resource management, whether it's in forestry, for example, predicting the future, whether it's in conservation, whether it's in agriculture, using advanced tools like here in Latvia to do machine learning to verify that farmers are saying what the sentinel imagery is observing. It's just profound. Your work is laying the foundation for the civil society with land information. Here in the Baltics, your work is leading the world. It's some of the most modern land information systems anywhere across Europe and anywhere across the world. And it's not just the foundation of the cadastre, it's its applications in forest management and in agriculture, etc. These examples show the application of GIS in planning and urban design. And here in the city, right in this very city, GIS is a foundation for organizing and thinking about and realizing a new city. In Abu Dhabi, they're building new towns. In Korea, in Incheon, they're doing urban redevelopment. GIS is at the heart, providing geographic knowledge, for visioning a better future, for creating more sustainable cities, creating green infrastructure across urban spaces. And GIS is going into buildings, into digital twins of whole cities, creating smart city ecosystems, building automatically, procedurally based visualizations of cities and going right into rooms and managing spaces and assets at the room level. These examples show applications of GIS in transportation, and they could be airports, they could be railroads. This beautiful example in the lower right is one of my favorite because it's showing maritime navigation lighting. And look at the little red map. As the polar ice cap is melting, the Canadians are picking out corridors for shipping across the Arctic. In the area of public works, GIS is organizing not only asset management, but the field workers, taking them to the field, optimizing their routes, creating more efficient infrastructure, and look at the interesting dashboards. Dashboards of field work, dashboards of street cleaning, and I like this particular map, this red one. This is in North Dakota, that's in the north part of the United States, and the red areas are where there's fault displacement in sidewalks. That's because they have a lot of freezing up there, so the sidewalks are, they're predicting where they need to have repairs. In utilities, not only is GIS managing assets, like in Latvia, the Riga Water Organization, but also analytics of assets. The cellular expert technology is now world known for telecommunication wireless planning. And here again, we see lots of dashboards of real-time information showing outage, showing voltage, showing real-time equipment tracking, and in the lower left in Estonia, vegetation mapping and its conflicts with high-tension transmission lines. GIS is becoming powerful in business. It's like business woke up. They're trying to get the geographic advantage by locating in the best place, by logistics planning. In Lithuania, the post office, the postal service, is picking the best locations and planning the best logistic routing. These kinds of applications save 10 or 15 or 20% of the cost of logistics. Isn't that amazing? One company in my country, UPS and FedEx, their competitor, last year saved hundreds and hundreds of millions of dollars in more efficient routing, getting this geographic advantage. In the field of public health and demographics, we see Lithuania again leading the way with census and statistics mapping. And look at these important issues: opioids, cardiac arrests, health facility location, and tracking population growth. Again, foundation for understanding and acting. Cities, countries are safer because GIS is providing foundational information, looking at crime mapping, looking at predicting crime, looking at fire hydrant coverage there in Lithuania, and looking at national security at events like major get-togethers like football games. In the lower left, I'll call your attention to that red map, and it's showing the targeted areas where best money should be spent on additional public safety investments. Our world is changing, and as a result, we're seeing increasing amounts of natural disasters like hurricanes, flooding, fires, and GIS is providing a foundation for preparing for things like floods and responding to the disasters that are occurring. Finally, GIS is opening up. It's opening up with open data portals. For example, on the lower left in Argentina and in FEMA, providing all the data openly for anyone to use. But also an idea that was pioneered actually in the Baltics in Lithuania years ago, citizen engagement, a kind of collection by citizens of spatial data and more responsive government as a result. And a new concept, adopt. It's called Adopt A, like adopt a fire hydrant or adopt a tree. This is a program where citizens can actually adopt something of public infrastructure and take care of it, expanding public service staff. Cartography is the heart of GIS. It's how we understand it. And here there's a large spectrum, starting with DNA mapping, things we can't even see, all the way to global mapping of the entire features for the entire world. And here again in Latvia and also Lithuania, the cartographic organizations are making topographic maps in a completely automated and GIS way. In Lithuania, they're introducing new concepts for map generalization, automatic generalization from 1 to 10,000 to 1 to 50,000 work. This is very exciting to me. Finally, mapping is changing. With story maps, we're seeing stories told about everything, from bird watching and tourism in Lithuania to pupils doing research in their classroom, looking at climate change, looking at changes in ocean currents. We're telling you and your work are telling the stories of what's occurring geographically. Mapping is becoming enormously enlarged on the web. It's a new language. And it's a language, ladies and gentlemen, that you own. You are the authors of not only beautiful maps, but also the analytics and the powerful databases that feed them. I want to shift gears now and talk about a sense of vision about what's going to happen next. And so probably you might think when I say these words, I'm going to talk about what's next technically. And I will certainly do that. But I'd like at the beginning of this conference for you to take a moment and think about what's next for our world, and what does that mean to your country and to your cities and to your organization. And what does in turn that mean next for you and your families personally? Today, we live in a complex and interconnected world that's constantly changing. And we use geography, the science of our world, to both understand and predict what will happen in the human world and in the natural world. The pace of change is accelerating. You would agree that it's now creating many challenges. The changes introduced by human beings are threatening both our natural world and some would say even our future as human beings. This climate today, yesterday I was in Paris, it was summertime. We're now in a place where no humans have been before, and the evidence is clear from the messages about, the geographic messages about climate change and population, the loss of biodiversity, the challenges we're facing with energy and water and urbanization. We definitely, in our world, need more understanding. This is not about political polarization, going to the right or going to the left. This doesn't mean anything. What particularly makes you unusual in this room is you're not about the right or the left, you're about going forward with delivery of information and collaboration and action. So what should we do next as a human population? Well, people are doing lots of things all around the world to address these challenges. But you in this room, particularly you, can do something special, which is to apply the power of digital geography, the science of our world, to envision what's possible, to improve productivity, to create more sustainable cities, integrate environmental thinking, design with nature, and so on. Clearly, given the changes that are going on, we have to keep moving faster. We have to learn more. We have to understand more. We have to leverage our very best technologies, our best science, and our best holistic thinking and design. Wouldn't you agree? For me, this is the only way out, the only way forward. So what is it that we possess uniquely as a group? The science of geography, the science of where. And when we talk about this science, it's not simply the data. It's a framework and a process of how you do your work. You manage and collect data. You organize it in databases. You visualize it. You analyze it. You make models. Then you apply it in design and planning. Then you make decisions, and you support people who take it to action. So this language that we're talking about is much more than simply making a map. It belongs to a whole family of workflows and processes. This science of where is a kind of foundation for, well, what we call GIS, but it's also the foundation for simple mapping and location analytics. And it's also a foundation for unique applications in city planning or in taking GIS indoors or in the kind of applications that many of you build. And this world of GIS, this science is advancing rapidly based on more data, faster machines, and new innovations. In the data area, new tools for measurement, the new Sentinel satellites, but data of many types, crowdsourced information, IoT, LiDAR data, FMV, also faster and better machines, new ways to do things with computation. Machine learning is being introduced, not just in our field, but very broadly. And also there is forthcoming lots of new innovation, and I'll talk extensively about this. These three forces, together with just creative work, are resulting in a new pattern of GIS. It's no longer a mini computer or a workstation or a PC GIS. It's no longer a server-based GIS. It's no longer just map services. It's a web GIS. And it's a web GIS which is much more open and dramatically supporting much larger audiences. So a web GIS is a modern architecture which is helping everyone, from individuals to teams to organizations and communities. This WebGIS is built on web services. That's the connection between the clients and the services. And it engages everyone in the organization. And it calls from this whole distributed network of data. It's no longer just data in my data bank. It's pulling from the web services from many sources, from your colleagues in other agencies. And it's all about sharing and collaboration. That's the magic of this language. And what makes it so compelling? It's not just one thing, but it starts by being a much easier and more accessible and interconnected system. It supports web maps and web apps and smart mapping and hubs and solution apps and location analytics of many types. These web maps are data generated and driven, and they become the language of seeing 2D and 3D, connecting people and organizations and whole communities, a common framework. And they're supplemented or complemented with apps, the science of where apps, that take it to all people, to citizens, to executives, to boardrooms, into buildings, looking at massive problems like climate change or very specific problems. And one of the more powerful emerging apps is location intelligent apps. For example, this small app called Insights. We'll see that more in a few minutes. Opening up your world to everybody else in the organization so they can drag and drop and integrate and do analytics. And at the other end of the scale, we're moving to a world which has Earth observation, which when combined with GIS can make predictions. This little map is a map that takes forecasts of rain in the US 15 days in advance of the rain. It drops the rain on the stream network across topography, and then forecasts where there'll be flooding 15 days from now. And that might sound like a simple cartoon. It's a very complicated piece of work. So we are moving to a world where we're measuring, putting big data into large analytic engines, and being able to forecast using machine learning and AI tools way into the future. And we need this. We are wiring up the world for a digital world that supports the kinds of complex decision making that's going to be necessary. And my words for that, it's helping understand, predict, and make decisions at many scales. This isn't just for global scientists. This drills right down to your geography and your organization. GIS is also changing with this pattern, creating a kind of, driving a kind of digital transformation, which is helping organizations re-envision what they do. The first generation of digital automation is what I call it with GIS, is we sequentially did work, like make topographic maps. This set of workflows are now being plugged into a larger ecosystem of organizations with web services. This is transformational because it means that these different sets of work can be served using web services into a common framework. Integrated operations. That's changing how people think about their work because they're connecting the topographic map data with new satellite imagery in real time, with IoT data coming in, with other transactional systems. It's like working at the speed of light. And this is going to result in massive transformation so that stove-piped sectorial organizations and sciences can begin to unify their specific data using geography, using location as a common framework to bring things together. And you are the people with your technology that can actually enable this kind of transformation to occur. Now, this digital transformation, my thought, is just beginning. It's just beginning. This is only 2018, right? This is only 2018. And we're hearing about pieces of it. Automated vehicles, autonomous vehicles, robotics, data-driven analytics. These are all in the ecosystem of what's occurring. But this WebGIS space brings it together. And out the other side is pervasive geographic understanding. This is already starting, integrating geography and geographic thinking into virtually everything that people do. So how do we take this next step? Well, first, we need to embrace what's occurring, not sit as side watchers to this. We need to actually get in the game and embrace this evolution that's occurring. Take initiative. Envision a better future, a better world, actually. Better cities, better organizations. And you, this is a message for you in the room, you need to work together to share knowledge and collaborate. Learn continuously. This is a challenge in my life. I'm an old guy. I have to keep learning the new technology and push on it. And the outcome for this, I think, is a society which is enriched by the power of your knowledge, driven by a geoscience-enabled foundation for the future. Is this vision possible? Just Jack up here talking. I've done a lot of thinking about this, and I think it's not only possible, it's in some ways it's inevitable, given the evolution of change. So that means you as participants in this evolution are in some ways early days, like the early days of the internet or the web. Same kind of positioning. The transformation using the science of where language to address these challenges. Now, I'll shift now for a moment and talk about our work, Esri's work. Most of you know our organization. We have about 10,000 participants in Esri around the world. The way we see our work, the words are very important here to me. The way we see our work is to create useful technology. The way we see our work is to create useful technology that helps you do your work better. Each of those words is very important to me. And in the process, build technology which addresses some of these greater challenges that are facing all of us. That's how we see it. And the way we do it is through this instrument of ArcGIS. ArcGIS, as most of you know, is a comprehensive platform. It's open, it's services-based, and it can be deployed in a distributed environment. It supports individuals or whole organizations. That's the idea. How many of you own a smartphone here? Yeah. Well, there you go. See? Okay. It's now broken. So no, anyway. When I bought this smartphone, I didn't really realize what I was doing. I thought I was buying a phone. But I didn't realize it was integrated, this is an iPhone, integrated into the iCloud, and it had iMusic, and it had all kinds of stuff associated with one device. And in many ways, that's the way to think about ArcGIS. People buy a desktop, and they also get cloud ArcGIS Online with it. And with that are all kinds of apps. Or if I buy I buy one piece of it, and I'm buying into an entire ecosystem of technology. That's how we design it. It's designed to support three basic parts of an organization. One, the system of record keeping. These are transactional systems like cadastre or water or forestry. Second, it's a system of insights. That's for analytics. And third, it's a system of engagement. That means I can have an identity. Through my identity, I can have privileges to access certain data and not other data. So this is actually three systems in one, built around location and geography. So ArcGIS organizes and manages all aspects of geographic knowledge. First, the data and services that people create and it organizes them in a catalog, so I can search the catalog in a portal and find other people's data and services. It organizes apps and models. It also organizes and manages information products that are created by others. So all of this content side I can search and discover. But it also organizes people, their identities, and their people into groups using modern social techniques. So it brings all of those forces together in a simple-to-use, integrated experience for searching. What is the content in ArcGIS? ArcGIS actually accesses any type of data in a distributed environment. So I can have imagery on one server in one location. I can have tabular data in another server in another location, and I can view them harmoniously in the way of web maps. I can take unstructured data, 3D data, LiDAR data, bring it all together and mash it up through this language of maps and 3D maps called scenes and layers. And on that environment, I can do many things. So the remainder of my talk will be about what are those new things that we have been working on to support the basic product. And they are things in core GIS and also in location and simple mapping. Actually, it's one platform that supports these two different marketplaces. So we'll start with data management. So in the last year, we've been advancing by adding new industry data models, particularly in utilities, but also in roads and pipelines and bathymetry. We've improved 3D editing with Pro. We've integrated stereo into the platform and allowing better annotation. Look at the center. We've now also added unstructured data. So in addition to tabular data, I can take just unstructured information and throw it into the system and have it automatically geocoded. Finally, we've expanded the kinds of data that we're supporting, for example, complete SAP HANA databases and all of the popular cloud database environments. Last year, Autodesk Corporation approached us and said, we'd like to collaborate with you to integrate the design and engineering world with the GIS world. And so we've been working closely with them to integrate BIM into the GIS ecosystem, and also their civil engineering tools added to the GIS environment. The big picture here is to say the transaction world of BIM and design, conceptual design, detailed design, engineering, construction, can be integrated as a transaction into a smart GIS city. Now this is a big deal for me. I grew up as a planner and designer, and the GIS and engineering world have kind of separated. So this is an attempt to try to bring these two worlds back together digitally, and I think it will be kind of a foundation for one of the elements that makes cities smarter. The second area of innovation is in field solutions, and here field data collection tools like Collector and Survey 123 are being augmented with device trackers so that devices and thereby people are tracked in real time by enterprise dashboards that can also give advice and direction to workforces to optimize field work like data collection, coordinating work in the field. So GIS is becoming an instrument for mobile workers to connect them to the rest of the organizations. And in real time, observe that work. This application called Dashboard is one of our fastest growing new technologies. People are building dashboards about everything, as we'll see in a couple of minutes. They're saying we'd like to measure electric uses, IoT, where the workers are, environmental measurements, performance measurements, and now with a new web application with widgets, I can drag and drop and build dashboards in minutes. Arcgis Online is a huge cloud resource with thousands and thousands of living atlas layers in it. But it's also a place where millions of data sets have been shared by users. And so I liked what Linus did at the very beginning of the session. He said, meet somebody. Why is that so interesting? Because this cloud environment is like Facebook in the sense that people can share their map and other people can look at it. But looking is not enough. They can look at it, but they can mash it up with their own data in a collaborative environment. So Arcgis Online now makes about between 1 and 2 billion maps a day of people sharing and using each other's content. This is a very powerful environment. One element of that is called the Living Atlas, and my colleagues are going to actually show some of the maps of the Living Atlas in a moment, but it integrates imagery, like the new Sentinel-2 imagery, Landsat to the world. And by the way, I want to acknowledge some of you here in the room for your contributions to this environment with the Living Atlas. So, Agni, you want to give us a little preview of what's in the Living Atlas?
Yes, thank you. Living Atlas of the World is a collection of 1,000 authoritative items that are built by Arcgis users, Esri, and its partners. And there are some ways how you can explore Living Atlas content, and one of them is a web application. Here you can filter the data by categories like boundaries, people, by content type, time, and even by region. Now let's try to find world elevation layers that provides you an access to elevation values for use in analysis. Once you find the needed item, you can open it in an item description, and you can see all the metadata about this item, and you can also open it in a map viewer or in a scene viewer. If you are already signed in your portal for ArcGIS or Arcgis Online, you can also add the content directly from Living Atlas of the World. Here you can search the layers by layer name. You can filter the data, for example, by categories, by regions, or other. Now let's try to find the Sentinel-2 multispectral imagery, and let's add it into the map. Using the different renderer with this data, we can explore the world in different ways. Let's change image display and choose different renderer like agriculture. When the data appears, you can perform numerous analysis tasks. For example, you can measure various areas. For example, you can calculate the area of buried areas on the map, and you can also explore and combine these data from Living Atlas of the World together with other layers from your portal for ArcGIS or Arcgis Online. Living Atlas content is also accessible for ArcGIS Pro users. In the catalog window, you can search and find all the items. You can perform numerous analysis tasks or use the data for visualization. Like in this example, where I have Lithuanian elevation services from Living Atlas of the World as the ground within the scenes. And let's say I'm working in a regional park, and we are planning to build an observation tower in a wonderful place. So it's very important to know what height the tower should be to see as much the landscape as possible. So in this case, using interactive analysis tools like ViewShed, we can determine visible areas that are highlighted in green using the different observer point heights. All organizations with Arcgis Online can contribute their data to Living Atlas of the World. And this can be done using Contributor app. Here you can see all the items that are listed on my Arcgis Online content. And if the metadata of this item is completed, you can nominate it to Living Atlas of the World. And hereby your content will reach a broad audience. Arcgis users also can use numerous base maps. Esri this summer has introduced a new Openstreetmap Vectorbase Map. This base map is built using OSM data exclusively. It's hosted by Esri and updated frequently over time. And this base map is available as the new app, map, and layer item in Arcgis Online content, so it's freely accessible to any user who would like to use OSM data to create their maps and apps. One of the greater vector-based map feature is that they can be very easily customized, including both content and symbols. And here you can see an example of 1, 2, and 3 customized base maps, vector-based maps, that were made by customizing light gray canvas style that is provided by Esri. World imagery base maps is also constantly updated with digital globe data. Talking about the improvements, I'd like to emphasize that Esri is actively working with many organizations around the world to incorporate some of its data into Arcgis platform to improve the base maps and other contents that is available through Living Atlas of the World. And in this region, Esri is working with Estonian Land Board. And there you can see an example of work that is in progress for imagery. Here you can see Tallinn's Old Town in World Imagery Base Map. Let's turn on Estonian Land Board imagery, which will be incorporated into this base map, and we can see that this data is much more detailed. And with this great example, I'd like to encourage each of you to share your data through community maps programs and enrich the wider GIS community. And finally, if you are interested in previous imagery, you can use a Wayback Imagery. It's a digital archive of world imagery base maps that enabling you to access more than 80 different imagery versions captured over the past 5 years. And this is an example of how the same area in Tallinn looks in 2014, please make attention into this place, in 2017 and 2018. And for those who already has a specific imagery version in mind, a Wayback Imagery group is a place where you can find all the Arcgis Online items for each version and use them to create your wonderful maps and apps. Thank you.
Thank you. Great. Thank you, Agni. Appreciate it. So there are billions and billions of dollars of investment that have been made by different users in building these maps and now shared openly for use. The next area I'd like to mention is on the platform, the ability to do dynamic smart mapping. This is the ability to make beautiful cartography with simple data sets and open it up so that anybody can make beautiful maps. I mean, I know in this room there's some fantastic cartographers, and then there's people like me who are not such a great cartographer, but we're putting into the machine learning environment ways to render beautiful cartographic displays And this is dynamic display using modern technologies like WebGL that can create beautiful maps from spreadsheets or tabular data of any type. Mapping and cartography are a central focus. So for traditional mapping organizations, we've added new symbology and annotation, including military symbology. We've also made improvements in production mapping and charting, but I'll call your attention to the lower two on the right, which is maps for Adobe Creative Cloud. Now, Adobe Creative Cloud clients can be used as clients to ArcGIS services to do final map finishing, which is often characterized in newspaper publications. Also, we've been enhancing the maps for Microsoft products like Power BI and Maps for Office and Maps for SharePoint. So some of you may not be interested in this, but this is a technology suite that expands the use of your GIS data to everybody else in the office, everybody else in the organization. People want to make maps. They want to see it with their particular data. So we're going to have Donalus show a little bit about what's going on in cartography. You want to take it away, Donalus?
Thank you. Thank you. So there are many ways how to enhance your maps and how to make a more powerful impact to the audience of that map. And here you can see that I have made a map, and I want to link to a person called John Nelson, and he is an active contributor to the ArcGIS blog, in Twitter, in Facebook, and so on. And what he provides are many resources like styles, colors, symbols, and so on, what you can reuse in your own work. And in this case, I have used a Firefly style. So basically, it's just a resource, you download it, and you can use it, making beautiful maps. Another example is a trial to reproduce a hand-engraved block-printed map. So basically, it's like an engraved wooden block from which you print your map. And there is a technique how such result in ArcGIS Pro. So I have done the same as described by John Nelson, and this is what I get. Basically, it's like combining many pieces of scanned map to produce a differently new map. And what's also interesting is that you can apply the symbology not only to the vector data, but also to the labels and text on the map. Another example is using digital tools to reproduce hand-colored watercolor maps. And here I have also made such an attempt. So here is a basic view of my data. So this is like a lake depths. And instead of this view, I put a piece of paper and start drawing in watercolors, adding some additional pencil marks and pens marks, and above all of this, I put my digital tools I have used to make this map. And a very interesting example was making this map, and this is using the current precise topographical data to make a map look like it was made in a century ago, an antique style map. And I take Estonian topographical data, applied the symbology, use some tweaks, and this is what I get. And then, if you put this on a layout, you get a map like this. So this is a serious, antique-looking map, but not all your maps should look like very serious things. And the last thing I want to show is that the base map could be also drawn as a child would. So this is a vector base map. Agne was talking just before me, but symbology applied makes this a very different map. So thank you.
That's great. Thank you. Yeah. I might want to just mention that the shared information that lives in the Living Atlas belongs to all the users. It doesn't belong to Esri, it belongs to you. So as users contribute to this commons environment, it means that people are helping each other. That's the basic philosophy of the idea. And these cartographic examples show how we can exploit this commons environment of content in multiple ways. Not only in 2D, but also in 3D. Major advances in the last year through the JavaScript API and other tools are allowing us to exploit our traditional 2D maps in 3D visualizations. Here, cities, the whole globe, through augmented reality and VR environments, and so on. This is a driving force not only in visualization, but also in analytics. So I can do 3D view sheds, as we saw a couple minutes ago, and our active area of research is going underground with new voxel data models for looking at geology and oceans, as well as atmosphere. We're going to see a little demo from Taras. You want to show it to us on 3D analytics?
Yeah, thank you. So, as Jack has already mentioned, we have some new features, and with the latest release of Arcgis Pro, you can add colors and textures to your multipath features, allowing you to create very realistic looking models. So let me show you an example here. So I'm going to start by drawing a building here, and I'm going to use point cloud data to guide me. So I will draw the footprint, and let me find the point cloud data. So using point cloud data, I can snap 2 points so that I can capture the shape more precisely. Also, what's new is that you can actually edit each vertex separately. So let me show you how that looks like. So I'm going to lower this vertex here, and you can see that I captured the shape of this building. So now that we have the shape, what we can do is we can start adding textures. So I'm going to add a texture for this wall using the new tool called multi-patch texture. So let me choose a texture. So when I add a texture, I can set it the way I like so that it fits nicely with the building. So let me set it here. And I also want to add the roof texture just for it to look more complete. So I'm going to select a roof texture here. And just in a couple of minutes, you can have a very realistic looking building. Now, speaking about realistic buildings, did you know that you can actually add and view Revit models directly inside Arcgis Pro scenes? This is something new that came out of the partnership with Autodesk. So you can see an example here of a Revit BIM model. Now, if we look at the catalog pane, you can see that Arcgis Pro actually recognizes this model, and there are all these different groups. I can either add the whole model, or I can just add a single thing, for example, walls. So let's add walls. Not only is it displayed, but we can actually also look at the attribute values that Arcgis Pro is capable of reading. So if I identify an element here, we can see the attribute values. And I can use this feature in my geoprocessing tools, or I can just publish this to Arcgis Online or Arcgis Enterprise. So I've showed you a couple of new ways that you can add 3D content to your scenes. Now let's briefly talk about analysis. So let's imagine that, well, first of all, let me back up. So a few weeks ago, Pope Francis visited Lithuania, Latvia, and Estonia. Remember that? So imagine that I was one of the organizers for the Pope's visit to Vilnius Cathedral Square. So how can I leverage Arcgis 3D capabilities to make this more easier for me to organize? So I actually start with 2D data, and we often start with 2D data when we build the scenes. So here I have a pamphlet from Vilnius Tourist Information Center. It has all the different sectors and facilities on it. So what I did, I actually, first of all, I georeferenced this pamphlet using the Arcgis Pro georeferencing tools, and then I vectorized everything that I see here, and I put everything into 3D scene. And this is how it looks like. So when I have this scene, I can publish this to Arcgis Online and get something like this. And since we have the capabilities of JavaScript, we can do some sort of analytics. For example, I can measure I can also view the scene in my smartphone. So for example, I have the same scene open on my smartphone. I can pan around, I can click on items and get various details. Okay, so let's go to the analysis. So even without using any special tools, I can actually just look around the scene, to get different perspectives. I can use the animation capabilities in Arcgis Pro to actually animate the path that the Pope Mobile will take so that I can have a better idea how it will look like from the first-person perspective. Okay, so now let's look at the media coverage for this event. So I have a press sector here. Now my job is to make sure that the path that the Pope Mobile will take is actually visible from this sector to photographers and camera operators. So what I'm going to do, I'm actually going to use one of the new interactive analysis tools, ViewShed, and I'm going to place an observer on the press sector here. So let me do that, and then I'm going to expand the viewing angle. Now let's see, what do we have here? Okay, so it is just in a few seconds, it's clear that most of the path is actually visible, and only small parts are blocked by the screens here, which is okay. Now let's look at the security situation. So at high-profile events such as this one, we need to place some rooftop observers and to make sure that they cover certain areas for the event. So I'm going to use another tool called line of sight, and I'm going to place an observer on this roof, and I'm going to assign this observer to cover certain areas. So for example, this area here, this area here, this area here, and another one somewhere here. So immediately it is obvious that some lines of sight are actually blocked by the tree here. But I can actually move this observer around the roof to find the optimal spot so that all the areas are covered. Now, from the security point of view, it's also important to know what's going on underground. So we can use another tool called the slicing tool, which is probably my favorite. And I'm going to create a horizontal slice, and we're going to take a look underground. Okay, so I'm creating my little window to the underground world. So here we have it. Underground. I don't know what these are, so I can actually click C, and then what is this? A rain drainage system. Okay, I know that there are some tunnels underneath the cathedral square, so we need to find those. Where are they? Okay, these are here, I think. Yes, these are underground tunnels. So to look inside the tunnels, I can use the same tool, but I will create a vertical profile right now. And let's have a look. Okay, let's see. There's nothing inside this one. Whoa, whoa. Well, there is an alligator in one of the tunnels. We will make sure to take care of that. But anyway, these are just a few examples how you can use the interactive analysis tools in Arcgis Pro.
Yeah,
thank you.
Thank you very much. That's great. Well, 3D is not just in Pro, it's in browsers, it's in devices, as you saw. It's now ubiquitous across the platform. In addition to the third dimension, there's also the fourth dimension, which is real time. So increasingly, we are seeing our users take real-time sensor networks, integrate them through the Geo event server, and provide situation awareness or analytics or alerting. For example, these demonstrations show. GIS is becoming real-time. GIS is becoming 3D. And as we do this, it's resulting in big data, which requires a repository for very large volumes of collected information, like from sensor networks. Where have all the cars been? Where have all the people been? Where have all the registers in the stream gauges? What have they been looking like? So this system is a complete ecosystem of integrating real-time with big data analytics that can be batch analyzed to bring new sorts of insights. Imagery is increasingly becoming a major piece of GIS. The two technologies that ArcGIS supports are the image server, for taking all sources of imagery and serving it into analytic pipelines, and also the image analyst extension on the desktop extension to Pro. These two technologies allow us to both serve out and make accessible imagery for many, many applications, but also do high-end exploitation of imagery for applications, for example, change analysis and the like. Speaking about analytics, there's two worlds. There's the big data analytics, there's the traditional geoprocessing analytics, and then there's this new exploratory analytics. Insights is the technology that we've developed for exploratory spatial analysis, and in many ways it resembles business intelligence or BI platforms like Tableau or Power BI. But this integrates spatial analytics into it. And so Elsa's going to show us a quick demonstration of how Insights actually works. Elsa?
Thank you. So today we would like to understand the situation in Kaunas City about the advertisement permits. But firstly, I would like to say thank you to Kaunas City, who has used GitHub to publish their open data. So let's start the work. We can easily see on the map where are all advertisements located all around the city. We can see which advertisement company has how many advertisements, and of course we can easily access the information that in total at the moment in Kaunas City there are 1,543 advertisement permits. Of course I can just click on the company and see where this company has chosen to put its advertisements. If we look more into the data, we can see that there are two types of advertisements, and most companies choose to use signboards, not the stands. So from city perspective, I could think that where should city invest money if more companies choose to use signboard advertisements, not only stands? And also, from the city perspective, sometimes they need to think that the amount of advertisements probably isn't the main value that they need to think about. We can also think about the areas. And when we will make spatial filter to understand how many companies have advertisements in space more than 20 square meters. So, as a result, we will get that the company who has the most advertisements isn't the leader in the space. This is another company who has only 12 advertisements located all around the city. Also, from the city planner point of view, I would like to show you how easy it is to add the advertisement data on the map and to make it spatial. Also, it is important that those are not only the points where the advertisements are located, but we can also make a heat map and understand the spatial attribution of the data. So we have two kind of different maps about the same data sets. Last but not least, it is also important to understand the count of advertisements, but also about the population, how many people live in these areas, so we can easily drag and drop the information and add advertisement spatial aggregation on the top of the population, so we can understand that actually at the moment, where there are the most advertisements isn't the biggest population living. Also, the new link analysis shows us the relationships between the data. And in this scenario, of course I can see which company has chosen to put their advertisements, but as I'm thinking from the city point of view, for me it will be more important to understand that there are places which companies choose to put their advertisements, so we can think maybe in this place there are too many advertisements and we need to increase or decrease this number. And if I'm responsible for planning these advertisements, of course I also need to give the information about the validation of the advertisements agreements. So me, as a city planner, I can make a page where we can see all the information. For example, the company who has the most advertisements has its agreements only till May 2018. But the company who has the biggest space of advertisements has advertisements even till 2023. So me, as a spatial planner, I can make a shared page to my colleagues with the filters, so they only can access the information about the agreement timetables, and I can share this page and share it to my colleagues, so they do not need any login, and they can access this information what they are needed. So with insights for ArcGIS, we can, from raw Excel data, we can get meaningful results. Thank you.
I mean, Elsa went so very fast that it seemed like she was a GIS professional. She is, of course. But non-GIS professionals can drag and drop and magically explore tabular information using the power of spatial analytics. This is a whole new market for your content and for you inside of your organization. It's not the traditional spatial geoprocessing work. It's a kind of opening up of using location as a mechanism for exploring data as opposed to pre-thinking geoprocessing. You start, you back up, you re-explore, you re-examine. So Elsa, I have a question. How long did it take you to understand the data you were working with?
Actually, it really wasn't a lot of time.
A day, a week?
Probably 2 days.
2 days. So again, the emphasis is not on the technology, it's on the exploration of the data. And so she saw relationships in the data through exploring it. That's the main idea. Thank you. For those of you who are doing science, and particularly big data science, we keep moving the envelope by adding new spatial statistical tools, new charting tools, new raster analytic tools to the environment. There are already 1,200 of these. This year we added 60 new ones for especially space-time cube analysis is very important. Also, how many of you are interested in AI and machine learning? I suppose most of us, actually. I mean, you should be, because it's showing up everywhere in hospitals to help us understand our body, in driving, and just about every piece of work is being affected by AI, or at least if you read the newspapers, that's what they would like you to believe. Now, inside of ArcGIS, we have two basic initiatives. One of them is in machine learning. And it turns out that ArcGIS has many machine learning tools in it already. Things like prediction tools for classification or regression analysis. These are basic, fundamental machine learning tools. You'll find them in the literature. And we're adding new ones this year. That's in the desktop. The other world is in the cloud. And so we have supported the idea of integration with very large platforms and frameworks for doing deep learning, as it's called, or AI work, by integrating our desktop with machine learning tools for developing training data sets and basic work with these large cloud environments that can manage thousands or tens of thousands of images or other observational data sets. This is an active area for ESRI. We have dozens of people working on it, and our vision is not to build new AI tools. It is to integrate our desktop and our web tools with large AI environments so that people, when they're doing their normal geoprocessing work, can be advantaged by this new and emerging environment. Now, there are quite a number of tools in ArcGIS in the way of clients. There's the desktop client, Pro. There's the collector field clients. There's viewing clients, and so on. But for some of you, you're interested in building your own apps. There are two environments for building apps. The most popular one is web JavaScript API-based apps. And here, the web app builder allows users with no programming to build web apps that run on anything. Last year, over 500,000 new apps were built on the open web on our platform, and that's accelerating. Also, for those who are interested in native apps, there's something called App Studio that allows people to build high-performance apps that can be connected and disconnected anywhere. There is an environment at Esri called the Arcgis Solutions team who build open source apps and they share them. There are actually hundreds of these, some for local government, some for utilities, some for emergency management, and some for defense and security. These are apps, tools, data models, workflows that we have built in association with our customers. So users work with us very closely to model a cadastral workflow, for example. We take the code from that and put it into GitHub for sharing. Last year we had over 500,000 of these sets of open source code shared and used. This is one user being advantaged by the work of another user. It's a classic open source environment. And this year we decided to take those basic tools and make them available as configurable solutions. For example, a whole water company can grab not only individual solution components, but an entire configuration of a water organization with multiple apps. These are allowing our customers to very rapidly get value out of a new application area, and it's a big part of our investment for ArcGIS. The last base technology I'll talk about is a new one. It's called Arcgis Hub. And the concept of Arcgis Hub will be talked about in great detail this afternoon. But this is a way that our users are connecting, a new way that our users are connecting with their communities. It says, I have my own GIS in the city, but I'd really like to not only make my data openly available through a portal, but I'd also like, at the policy level, like at the mayor's level, organize my policies to connect with citizens. Why? Because I want to tell the citizens what my government is doing, but I also want to get my citizens actively involved in carrying out the missions or the initiatives in cities. And so very popular these days, the idea of standing up a community portal, giving every person in the community an identity. I'm Jack, I like trees, I want to get engaged in tree planting and greening of my city. I'm very worried about traffic death where pedestrians are crossing. And the mayor told me he has a policy initiative where he wants to work on it. That kind of thing. And also, I'm a city mayor. I want to show my citizens with a dashboard how we're doing, say, in crime, or how we're doing in street paving, that sort of thing. So this is taking GIS to the next level, to a societal level. And it's a beautiful little piece of technology. We'll see it demonstrated later today. We're now going to see a little demo from Montes. You're going to show Hub, or what is your plan? If you have time, yes. Okay, go ahead.
Okay, thank you. So today let's dive into a pilot project for Arcgis Hub initiative that we called Vilnius Bicyclist Friendly City. And this pilot project is based on actual data and efforts by Vilnius municipality to improve city's bicycle infrastructure in near future. So this initiative, as well as Arcgis Hub, is under consideration by Vilnius municipality at the moment. The first action that citizens can make in Arcgis Hub is a simple login using social links. So let's log into this initiative, and you see that automatically it creates a user for me. And that user can subscribe initiatives, updates, events, and use other ArcGIS capabilities like feature editing if it is permitted by initiative owner. In other words, it means that citizens now can do the same and have the same capabilities as municipality workers while using Arcgis Hub. For a simple review of this initiative, citizens can choose not to log in, but in this case, let's keep us connected. Using this initiative, the Vilnius municipality is aiming to inform community about status of bicycle projects, discuss future plans with the community about bicycle infrastructure development, and empower citizens for mutual data sharing. To achieve this goal, municipality shares a map of Vilnius bicycle infrastructure for the community to easily get to know what the current status is and what is planned for the future. Like in this example, you can see current bicycle tracks in green and planned tracks in orange. Right below this map, some statistics are shown. For example, the second number indicates that there are almost 34 kilometers of new bicycle tracks planned to implement until the end of 2020. That is a great news for bicyclists. As these maps and statistics are interactive, they help to update the community about the progress of bicycle tracks construction in near real time. To track what is going on in Vilnius, some detailed statistics are shown in a separate gallery. Let's dive into one of these dashboards and see how many issues were registered in Vilnius city and how municipalities solved these issues. So we can see that there were more than 500 issues registered since 2016, and more than 58% of them are already solved. However, all other issues will be solved with complex long-term projects until 2019. Let's back to our initiative. All these dashboards and maps and data shown in this initiative comes from Vilnius municipality Arcgis platform. And just below these dashboards, citizens can easily access sustainable movement plan prepared by the municipality. This is a roadmap for how cities' transport infrastructure should develop in the near future. Furthermore, as one of the most important features of Arcgis Hub is the ability for citizens to add data, we implemented this simple survey that helps us to collect the feedback and improve this initiative. On the other hand, as logged-in users have the same capabilities as municipality workers, we can insert a map here and collect, for example, places where people usually park their bicycles. Also, Arcgis Hub has a function that allows citizens to subscribe to the initiative and get news, updates, and notifications if something changes. So let's subscribe to this initiative. Lastly, initiative owner can organize community events with Arcgis Hub. Here you can see a calendar with all upcoming events related to bicycle initiative. And for the moment, we have only one demo event here. So let's see what it's about, and maybe we can register to it. So this is a short description about the event, and I see that I am already attending that event. So we will continue to improve, to make improvements to support Vilnius efforts to improve cities' bicycle infrastructure and other initiatives. And thank you.
Thank you. That's great. So what Montes was showing is a kind of engagement. I mean, we are all getting engaged in various social media environments. This is a way to do it around maps and do it around cities, initiatives, and real issues that people care about. I'll conclude my talk about talking finally about the developer aspect. We support 4 ways for developers to build custom applications and integrations. One of them is the Python API for integrating things like Python notebooks or Jupyter notebooks, or accessing and automating various aspects of the tool. The second is Extending Pro. The third one, and perhaps for me most powerful, is the JavaScript API, which allows client-side, browser-side geoprocessing and visualization apps to be supported. And finally, the native device apps for connected and disconnected sorts of workflows. This is a powerful set of tools that allow users to extend the basic platform. The JavaScript API, as I mentioned, is my favorite, and we already saw some examples of it here. Those of you who are not technical, it's kind of like a little software library that can live inside of a browser and do client-side visualization and geoprocessing in the client. So if I stand up a server, I can actually make really cool little applications in my browser. As a developer, this is very powerful. And it's also, as you can see by these examples, very, very, very fast. So for citizen-facing or just normal people facing, they want a user experience that's fast, analytic on any device. The other big one is Python scripting. At the bottom end of ArcGIS now, we've extended and opened the complete platform for new kinds of data science platforms like Jupyter Notebooks. So that if I'm in Jupyter, I can do data science integration with other platforms like R or other open source environments that I want to bring the power of community coding right into the platform, or vice versa. Also for the desktop, Python allows us to build with ArcPy various kinds of scripts to be able, again, to automate or do fundamental data science. Now, to make this platform work, it's required that we have a strong philosophy of open and interoperability technology. And we do this in 3 ways. First, we support all the open standards. In fact, we're active on many of the open standards communities for format specification and API specification. Second, we do a lot of integration directly with other COTS, commercial off-the-shelf products, like the Autodesk products, such as Revit, and there are many more coming. And the third, and perhaps most important for some of you in the audience, is that we are an open software platform. That means open data access, open APIs. It means integration with open source technologies, and also open sourcing the top of our basic platform. Finally, it's an extendable open architecture so that developers can extend it with other cool, interesting technologies. And the evidence that this strategy of open interoperability works is that tens of thousands of implementations that our customers have done with heterogeneous, multi-vendor technologies. Well, ArcGIS products are going to be talked about this afternoon. This is Pro, Enterprise Server, the online product, and also this new solutions environment of open sourcing solution apps. And that will continue advancing. We spend about 31% of our revenue globally on R&D. We have thousands of people involved in software development. So my commitment to you is basically to continue evolving the base platforms that you use. And I've given you some hints of what we're doing on an ongoing basis. But what's next for this? We'll just continue evolving the platform based on new technologies that emerge, new data types that we support, new ideas that you have for us to work on, and also just new innovation. These are some of the big topics that we're working now on in the various labs environment. And then, of course, quality and performance and innovation. Now, we like to think we're really good at times, but also, as Linus pointed out, we also make a lot of mistakes. And the only way that we know is through you and your feedback. So I really want you to take this occasion during these next few days to give my team feedback about what both is problematic with our software, both on the tools and the business side, but also what you want us to work on. This is very important for us. So Esri is all about you. serving you. That's how it's organized, both on the business and technical side, and also advancing our basic science. We are very strong. This year we're growing about 12% again, and have a strong engineering and science basis. We also care a lot about education and also about conservation, and also facilitating meetings like this for you to enrich your personal and professional development. There are many resources on this. I've talked a lot about software, but there are over 100 books that are about helping you learn and understand tools. We're now increasingly going with web MOOCs and other online training to assist you along the way in your efforts. Worldwide, Esri is also committed to education, not only at the university level with labs licensed to universities, but also in the secondary schools. Currently, we have over 3 million students who are registered around the world who are doing project-based learning and STEM education. And here in the Baltics and here across Europe, we have a grant in partnership with the EU, the Commission, to drive our technology for free to all secondary schools. That's a big commitment, but teachers need help. So there is a program in Esri called Geo Mentoring, and this Geo Mentoring involves people like you adopting a school or adopting a teacher and getting active in supporting K through 12 or secondary school education. Listen, I've talked a lot this morning, and I want to close with this statement, often credited to Charles Darwin. It's not the strongest of the species that survive, or even the most intelligent, but the ones that are most responsive to change. And today, it appears that we are exponentially changing our little world. And this is creating some very serious problems. We see it every day. And my sense is this is fundamentally threatening our life support system, the air that we breathe, the food that we eat. And it's clear to me also that the arrows are going in the wrong direction globally. We will need to transform our understanding of the world and also how we carry out our personal and our organizational responsibilities as participants. And again, this is not the political polarization world. This is about just you and me. It's also my sense that GIS, your profession, provides the best platform to really rapidly scale the kind of work that's going to be necessary to be able to turn this around. No kidding. This is not a joke. So our collective success in these applications, I think, will not only help create, but also inspire what's next. And for me, we have got to imagine that what's next is a better future. So ladies and gentlemen, thank you very much for coming to this meeting, and thank you very much for listening to my talk. We'll be meeting with you during the week. Thanks.